Alright, today is a bit different. I'm not explaining anything. I'm not going to draw anything out, but I'm just going to explain a bit of cool things I did today. So, I love durians. I can't lie, I love durians. They're one of the best fruits of all time. And so, while training for my AI Olympiad, came across this really cool dataset. It's called Durian Image, and guessed it, it's all pictures of durians. This is a dream come true. Like, seeing this is like, wow, I love durians. And you keep hearing people say, oh, I got scammed by the durian shop. It's not actually Mao Shan Wang, it's like some random variety. So, of course, I'm here to like solve this. So let's try solving this using AI. So, I have imported the data into Jupyter Notebook. It's a place for you to write code and run things on GPUs for free. Basically, a GPU is a thing that allows you to run specialized software like AI very, very quickly. So here I've imported the data from the Durian image dataset into my Jupyter Notebook. And this is just printing all of the files. In total, we have many, many files. And here's where the code begins. I'll try to just run through every block and explain what each thing does. First of all, import torch, import torchvision. These are the Python libraries I'll be using. This is called pytorch, it's very popular. And this is some code to make sure that I can use CUDA, which is the software by NVIDIA, which makes GPUs, to use the GPU instead of the CPU when it's available. Next, I said approach 1 because I was planning to do more, but then I got lazy. So the approach we'll be using is fine-tuning a ResNet. A ResNet is a very powerful model that is a very powerful type of AI computer vision model that uses residual networks. I won't go into ResNets because that's going to take too much time, but I'm going to be fine-tuning a pre-trained model. What that means is someone else trained this AI model to detect something else. I'm just taking that and adapting it to what I'm doing now, which is training durian classification. Okay, so here I have a dataset of my durian images. I'm loading it into the software, and I can print the classes and indexes, which will show me the mapping which it has. So classes means the things that I can classify into. So for example, this data is D101, D13, 982, 288, etc. A lot of different types of durian. And they map into numbers for the purposes of the program, so they can classify it to a number instead of text. So this is a mapping so that we can convert the numbers back into text after the program is done. Right, so here we are loading data into a data loader so that we can pass it into our model. And then here we import the ResNet 50 model, which is the ResNet I was talking about just now. And we use these default weights, which means that they're taken by default from a pre-trained model. Now we jump to the topology. This first part here is quite special. I'll just go into this part here to explain more. This is a very cool feature of torch info that allows us to print what the shape of the model is. You can see, under the ResNet there's a lot of different things that you probably won't understand, but there's a lot of big numbers, and each of these numbers is one thing that the AI has to learn. So in total, there are 23 million parameters, 23 million numbers that the AI has to tune, so that it can make better decisions. However, not all of these have to be relearned, because again, these are taken from something else. They're already quite knowledgeable about image classification, and as such, we shouldn't have to train the entire thing. It's like taking a grown adult and like teaching him everything from primary school, like elementary school English, all the way to high school, just for him to do, let's say, statistics instead of mathematics. Like, you wouldn't need to go back to the basics. You just need to do some specialization on the final parts of education. So instead of teaching him math, you teach him stats. Similarly, what we're doing here is we take this last model, the FC layer. It's called FC as you can take from the model. It's the last layer here. And basically this is the last model, the last layer of the model. Instead of what is used previously, we replace the last layer, which is what comes out, with a simple linear layer, which means that for every input it takes in a set number of inputs, and gives out a set number of outputs. So in this case, it takes 204 inputs that comes from the model definition itself, and we want to output len train ds classes. This means we want to output one output for each class. This output will be the confidence it has of each class on whether or not it is that type of durian. And so from the confidences, we get the one with the highest confidence, and that's our prediction for whether that's the durian we want or not. And lastly, this part, what this is for every single parameter in the model, everything you have to learn, we disable requires gradient. What this means, let's not go into detail, it just means that you won't need to update it at all. However, when we add this linear layer, we're adding it after we're setting this statement that wants us to disable everything. So let's walk through this one more time. Here you get the model, the pre-trained model with pre-trained weights. So everything is mostly working, but for another task. Here we disable all of those weights so that they will be used for prediction, but they won't be. Yeah, so they will be used for prediction, but they won't be used for I got interrupted, sorry. They will be used for prediction, but they won't be updated through learning. But this one comes in after making everything set for not learning anymore, and then we will put that model in. I wish I could draw right now, but I don't have the drawing software open. Basically, this means that we will only let the AI learn to update this final layer instead of updating the rest of the model. And we do that. So this is all the training code. Let's not look into that. And we have some very nice statistics. Say slowly as the model trains from 0 iterations to 15, it jumps from 50% to around 80% accuracy. That's not bad. And then afterwards, here we're reaching a static point. So instead of not letting the earlier layers learn from the pre-trained weights, we actually give it the opportunity to learn, because again, it's a different task. There's a possibility that the earlier pre-trained layers are useful to be updated. So we unfreeze it here, and then we train it just a bit more, and you can see we get accuracy up to around 90%. And so now it's time for us to test it. I downloaded a random durian image. It's a D24. I passed it into the model, and it correctly predicted index 6, which you can tell is D24. However, D24 is quite a common durian, so it is possible that it's just guessing the most common type, especially because the durians all kind of look the same. So download another durian. Actually, let me show you the image now. This is the image. This is the image of the durian that I downloaded from the internet, and I passed it through the model, and it's wrong. This is supposed to be D88, but it predicted as a D2. So, not very good. A fair assumption is because if we look at the data again, this is the data we passed in, it's all kind of the same, like one durian in the center, white backdrop. But again, other information, like other images like this, it's not like that. The background isn't like a pure white background, and so there are different, the AI model might be very, very confused by this. So what can we do from here? We can get better data, we can get more varied data so that the AI is used to this. We can augment the data, so instead of having a pure white background, we can make it another color, we can skew, we can increase the brightness, decrease the contrast, things like that to make it even more confusing for the AI so it can learn to generalize to more scenarios. And lastly, maybe segment the durian. So instead of trying to pass it the entire image like this, we try to just crop out the sides of the durian, and then we just, so it's like removing the background basically. You remove the background and only pass in the durian to the model and see if it can detect from that. So this has been quite a wild explanation. Maybe tomorrow I'll try using the actual, actually tomorrow I won't make a video, tomorrow I'm going out, but yeah, I'll try to use maybe the actual drawing software to explain what a pre-trained model is. Hopefully that'll be more useful. Right.